Okay, here's an example problem with some subnetting. And in this problem it says, given the IP address and the subnet mask, find the subnet ID. This is a very important thing to know how to do because this is the first thing that any host does when it wants to send an IP packet. And so any host that is configured with a TCP/IP stack will have both a IPv4 address and a subnet mask as part of the parameters that you set up when you set up your networking, in addition to the IP address of your gateway router and the IP address of a DNS server. And so this is the very first thing that a host does whenever it wants to send an IP packet out. It asks whether or not the destination IP address is in the same subnet as the host's existing subnet. And so what we're looking for is the subnet ID of these subnets. And the basic idea is, well, I'm going to do it just the same way your host does. And that is by taking a logical, a bitwise AND operation between the IP address and the subnet mask. Okay? And it turns out that 255 is 8 ones in a row and 0 is 8 zeros in a row. Anything ANDed with a 1 is its same self. And therefore any number, any octet in your IP address ANDed with the 255 yields the same number. Any octet ANDed with a 0, any bit ANDed with a 0 gives a 0. And therefore, the first 3 octets are going to remain as 10.20.10 because they have 255s here. You're ANDing with all ones. Anytime you AND with the 1, it stays the same bit. Here, the 15 turns into a 0 because we're ANDing it with a 0, 8 zeros. Okay, anytime you AND with a 0, you get a 0. And so the answer is, in very short order, subnet ID is 10.20.10.0. Okay? If you want, we can go ahead and write out 10 in binary is 8 plus 2, which is in 8-bit binary, 8, 4, 2, 1. 20 is 16 plus 4, which is 0, 0, 0. And there's a 1 in the 16's place, a 0 in the 8's place, a 1 in the 4's place. And so what we can do, and the 15 is, let's see, it's 8 plus 4 plus 2 plus 1. Ah, yes, it's 0, 0, 0, 0, 8, 4, 2, 1. Okay, it's 1 less than 16, so it's all 1s at the end. And so if you want to look at the full-blown calculation, what we've got is 10, which is this, dot 20, which is this, dot 10 again, dot 15, which is this. And we're now going to AND that with 255, 255, 255, 0. The 255s are 8 ones. And you'll notice I'm putting the ones right underneath their corresponding bits in the IP address. And then the last octet is 0, which is 8 zeros. And now I'm going to AND these two. And the only time I get a 1 on the AND is when I have 2 ones. Otherwise, it's a 0. There's a 1. Here's a 1. 0, 0, 0, 1, 0, 1, 0, 0. And you can see here that the ANDing with the 255s or the all ones leaves the byte the same. You can see 4 zeros, 1, 0, 1, 0, 4 zeros, 1, 0, 1, 0. 3 zeros, 101, 0, 0, 3 zeros, 101, 0. It leaves those bytes the same, and it zeroes out the last byte. Because anytime you AND with a 0, you get a 0. And so the subnet ID really is 10, 20, 10, 0. Okay? You don't have to do this very many times to realize that from now on, every time you AND with a 255, you get the same thing back, and every time you AND with a 0, you get 0. Okay, so this is the subnet ID. This is a Class C subnet address, subnet, and this is a Class C network ID. Okay, the next one, good. Just 255s and zeros again. This is a Class B subnet mask, and it leaves the first 2 bits fixed and zeros out the last 2. Okay, that's easy to do. Okay, and you can do that from now on. Here is a little bit more interesting problem. Now we have just 255s and zeros, we have a 224. What about this 224? This is one of those special numbers that appear in subnet masks because 224 is 128 plus 64 plus 32, meaning it's 11100000 in binary. Double check. Here's the ones place, 2, 4, 8. 16's place, the 32. There's a 1 in the 32, a 1 in the 64's place, and a 1 in the 128's place. And subnet masks always have numbers that are either 0, all ones or all zeros, or if it's something in between the 255s and the zeros, it has all ones to start with and then all zeros after that. In any case, now what we're going to do is we're going to use our rule, and we're going to leave the 10 and the 20 fixed because they are with the 255s. We're going to zero out the 15, and we've got something interesting to do in the 3rd octet. And so let's write out what 150 is in binary. It's 128 plus 32. Yeah. So 150 is a nice number. It's a 1 in the 128's place, a 0 in the 64's place, 1 in the 32's, 0 in 16, 0 in 8, 4, 2, 1. Okay, so I can take the 150 and I can AND it with the 224. Let's do that. 1, 1, 1, 0, 0, 0, 0, 0. And here's our 150. 1, 0, 1, 0. 0, 0, 0, 0. And let's see, I'm going to get my 150 right back again, aren't I? Yep, I am. So it's not as interesting as it could be. Okay. Okay, another way of looking at this is, just a second, 150 is not 128 plus 32, John. Sorry. It's 128 plus 22. Yeah. 128 plus 16 plus 6, which is 4 plus 2. I did something wrong here. Okay, well, bear with me. We only lost about a minute here. So this is 1 in the 128s, 0 in the 32s, 1 in the 16s, 128, 64, 0 in the 32s, 1 in the 16s, 0 in the 8s, 4, 2, and then 0 in the 1s. Okay, much better. Let's try this again. 224 ANDed with 150 is 1, 1, 1, 0, 0, 0, 0, 0, ANDed with 1, 0, 0, 1, 0, 1, 0, 1, 0. And when I do the AND, I get 1, 0, 0, 0, 0, 0, 0, 0, which is 128. So the subnet ID, finally, is 10.20.128.0. Okay? And again, the first and the second octets are left unchanged. The fourth one is zeroed out. And the middle one we got from doing our AND operation bitwise. The other way you can do this is to say that in the third octet, a 224 means that we have 3 bits for our subnet bits, meaning that we have 8 subnets. So we're going to divide the third octet into 8 groups of 32. 8 times 32 is 256. 8 groups of 32, and we're going to count by 32s. 0, 32, 64, 96, 128, 160, 192, 224. And we're going to ask ourselves, which range does the 150 fit into? And the 150 fits in here, because 150 is in between 128 and 159. Okay? It's in between 128 and 150. And the 150 being there means that this is going to be a 128. Okay? That's another way of looking at it. Here in part D, now we have another interesting one. We got 3 255s, but now we have a 240. 240 is another one of those special numbers. It's 128 plus 64 plus 32 plus 16, which means it's 1, 1, 1, 1, 0, 0, 0, 0. And 150 is again like above, if I do it right the first time. That, and so if I AND these together, I get 1, 0, 0, 1, 0, 0, 0, 0. And this is, let's see, it's 128 plus 128, 64, 32. That's the 16s place. 128 plus 16, which is 138, 144. Therefore, the subnet ID is, it leaves the 10, it leaves the 20, it leaves the 10 because of the 255s, and then the 240 ANDed with the 150 gives me a 144. Okay? And let's see here now. We can do this an alternate way, just like we did the previous problem an alternate way. When I see a 240 here, I know that I've got 4 bits for my subnet, and that means 2 to the 4th, or 16 subnets. And 16 subnets on the 4th octet leaves me with 16 IPs each. 16 times 16 is 256, so I'm going to count by 16s and see where the 150 fits. And if I count by 16s, I get 0, 16, 32, 48, 64, 80, 96, plus 16 is 112, plus 16 is 128, plus 16 is 138, 144, plus 16 is 160, 16, 176, 16 again, 186, 192. There's another familiar number. 16 again is 208, 224, 240, and then it would go to 255. And we want to ask, where is the 150 in this stack? The 150 is in between 144 and 160, so the 150 is here. And indeed, that's the one we found it in. So you can do this either way. Okay, hope that helps.